Independent of method of application, some of any applied herbicide reaches soil. So previously we talked about the association between herbicides and plants. So foliar applications may be washed off from foliage to soil, and other herbicides are applied directly to the soil. Understanding the interaction of herbicides and soil is thus an essential aspect of proper herbicide use and environmental care. Actually, there are three major concerns about herbicides in soil. The first is the reciprocal equilibrium of exchange and distribution of any material in the liquid, soil, and gaseous phases. The second is an herbicide's susceptibility to degradation and its rate of degradation. The third involves possible influences of herbicides on soil, soil fertility, and soil microorganisms. After soil application, there is no immediate direct contact between an herbicide and plant roots or emerging shoots. The physical processes of diffusion in and mass flow of water bring herbicides to plant roots. These processes are necessarily weather dependent, especially on rainfall, and the dose that creates a biological response is a function of weather, soil properties, and rate of application. Some control of these factors is possible, especially in irrigated agriculture. An essential property of a successful soil-applied herbicide is activity over a fairly wide range of environmental conditions with reproducible reliability. So these are the fundamental concepts and learning objectives for these topics. So the first one, the physical and chemical factors that affect herbicides in soil. Physical factors include placement, volatility, the evaporation, the adsorption, volatility, adsorption, and also soil moisture. This table shows the point of entry for any pesticide, the active environmental processes, and the interacting pesticide processes that affect movement and environmental fate. So take some time, pause this video, and look at this table. So the first physical factor is the placement of the herbicide. Some herbicides are taken up more readily by roots than by shoots and vice versa. This knowledge permits placement in soil to enhance or reduce uptake. Herbicides can be placed in or on soil to contact specific weeds or avoid crops. This seems obvious and easy, but it is difficult because control of movement after application is almost impossible. The next factor is time of application. Time of herbicide application can determine residual activity and soil persistence. Late summer or fall and early spring applications normally yield good phytotoxicity activity but decrease the possibility of leaching due to lower soil temperatures, then reduced evapotranspiration and a higher probability of rainfall. Application when soil is dry may lead to no or reduced activity and extend soil life. Next is volatility. Volatility or evaporation affects location. It changes a molecule's physical state from liquid to gas but does not cause chemical change or molecular degradation. Volatility can occur from soil or plant surfaces. Herbicides that volatilize from the soil surface move through the atmosphere, the easiest and most available route. Herbicides that volatilize in soil move laterally and toward the surface. Incorporation in soil decreases atmospheric volatility and is required for some aniline and carbomonoid herbicides. Adsorption is a process of accumulation at an interface and is contrasted with absorption. So this is add with the D, adsorption. So don't get confused with absorption. Okay. In soil, clay and organic matter surfaces are interfaces between the solid soil surface and soil's gases and liquid phases. Through cation exchange and physical attraction, herbicides can be concentrated at adsorptive surfaces and removed from the soil solution from which plant uptake occurs. Adsorption is one of the most important mechanisms that reduces herbicide concentration in soil solution, and few herbicides completely escape adsorption interactions. Adsorption affects movement and availability in soil and rate of degradation. It regulates degradation by soil microorganisms and chemical reactions. The adsorption's desorption equilibrium determines the amount adsorbed and the amount in solution and available for plant absorption. Okay, the equilibrium is the ratio of adsorbed herbicides to solution concentration and can be expressed mathematically given specific herbicide soil combinations. Next is leaching. This is a movement of an herbicide with water, usually, but not always. It's moved downward. It is of environmental concern because of the possibility of off-site movement and groundwater contamination. It can determine an herbicide's effectiveness by moving it into or out of a zone of action. So interaction with soil moisture. If soil is wet and air is dry, plants transpire more. Okay, roots absorb water from soil to replace transpired water, and herbicides in soil move to roots by mass flow. Okay, so this is kind of like physiological terms that you need to understand. More herbicide will be absorbed and phytotoxicity will increase. Sometimes dry air and wind cause rapid foliar water loss, and when not enough water is taken up by roots, plants will wilt. Stomata then close, water movement in plant slows, and herbicide uptake decreases. Soil drying can increase soil adsorption, okay, with the D, okay. Again, soil drying can increase soil adsorption, okay, and decrease root uptake. Rainfall or irrigation is essential to move herbicides into the topsoil layers where most weed seeds germinate. Some rain, perhaps an inch probably, may be essential to activate herbicides such as the triazines, which are taken up by roots. No moisture for 10 to 14 days after application can cause weed control failures. Heavy rains, on the other hand, may move herbicide below the zone of activity. Excess rainfall can leach herbicides through a zone of action unless they are adsorbed. However, the effect of soil moisture cannot be generalized for all herbicides, for all crops, or for any application times. You cannot generalize just by you cannot use the soil moisture as true generalization. Okay, we talk more on herbicides and soils in the next video.